Continue our discussion of circles. Today we're going to look at inscribed angles. Now an inscribed angle is an angle with the vertex on the center and the sides of the angle are chords. Okay? Each chord, its endpoints, make up the intercepted arc. And we also have, to help us find the measurements, we have the inscribed angle theorem, which says the measure of the inscribed angle is half the measure of its intercepted arc. So if we look at this first example, we want to find the values of A and B. If we start with A is the intercepted arc for angle PQT. Now we know that the measure of the angle, which in this case is PQT, is half of the intercepted arc, which in this case is arc PT. Well, I know that the measure of angle PQT is 60, and that is half of that intercepted arc, which in this case is A. So if we multiply both sides by 2, 120 equals the value of A. Okay. To help us find B, B is the measure of angle PRS, and it is half of the intercepted arc, which in this case is PTS. And I'm using 3 because it may or may not be a major arc. It's kind of hard to tell from the picture, but this will specify which way it's going to go. Now, the measure of PRS, that's B, and arc PTS is actually made up of arc PT and arc TS, and we actually have both of those measurements. So it's 1/2 of PT, which is 120, plus TS, which is 30. So B is 1/2 of 150, and half of 150 is 75. So A is 120, B is 75. In this example, we want to find the measure of angle A, but we're not actually given any measurements. What I do know is that this arc, which is intercepted by my angle, well, this is a diameter, which means this arc has to be a semicircle. What do we know the measure of a semicircle to be? Well, a semicircle is always 180 degrees. So the measure of angle A is 1/2 of 180, which is 90. And that brings us to a nice little theorem which actually tells us that any angle that is inscribed in a semicircle, so the endpoints are on the diameter, is always going to be 90 degrees. It's a right angle. So in this example, we want to find the measures of angles A, B, C, and D. So we got 4 problems to do here. Let's take it one at a time. I'm going to start with the measure of angle A. The measure of angle A is going to be 1/2 of its intercepted arc. So angle A is here. It intercepts arc BCD. Okay. So the measure of that arc. Well, that arc is actually made up of 2 smaller arcs. It's made up of BC and CD. And we can find both of those measurements because we're given those. 100 plus 90. So we have 1/2 of 190, which is 95. So the measure of angle A is 95. All right, now let's do the measure of angle B. That's going to be 1/2 of its intercepted arc. For angle B, it intercepts arc ADC, which is made up of 2 smaller arcs. It's made up of arc AD and arc DC, both of which we have the measurements for. The measure of arc AD is 64. The measure of arc DC is 90. So we have 1/2. 64 plus 90, we get 154. Take half of that, we get 77. Now let's go with the measure of angle C. It's going to be 1/2 of its intercepted arc. Here's angle C. Intercepted arc is arc BAD. Right. That's made up of 2 arcs. I don't think I have to continue writing out the arcs, but it's these 2 arcs of 106 plus 64. So it's 1/2 of 170, which is 85. And for our final angle, the measure of angle D is 1/2 of the intercepted arc, which is arc ABC. So we have 1/2 of 106 plus 100, which is, 1/2 of 206. Well, half of 206 is 103. So the measure of angle A is 95. Measure of angle B is 77. Measure of angle C is 85. Measure of angle D is 103. Not difficult, just sometimes a little time consuming. Okay, so we have some corollaries here for the inscribed angle theorem. Two inscribed angles that intersect the same arc are congruent because if angle A is half of this arc and angle B is half of the same arc, well, half of the same number, you're going to get the same thing, so A is the same as B. As we talked about in a couple slides ago, an angle inscribed in a semicircle is a right angle because it intercepts a semicircle, which is 180 degrees. Half of that is 90. And also, what you may or may not have noticed on the previous slide, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So angle A plus angle C is going to be 180. Angle B plus angle D is going to be 180. So let's use some of that new information now to find the measures of each numbered angle. So here we have angle 1. We're given that this arc is 40, this arc is 70, but if I look at angle 1, it intercepts this arc, which I have a diameter. So that means angle 1 has to be a right angle. So the measure of angle 1 is 90. Alright, well, what about angle 2? Angle 2 intercepts this arc right here, which is also intercepted by this arc, which means those two have to be congruent. So the measure of angle 2 is 38. In this example, if I want to find the measure of each angle, I know that first I have a diameter here. Angle 1 intercepts that, so the measure of angle 1 has to be a right angle. It has to be 90. Same thing with angle 3, right? Because they both intercept a semicircle, so it's 90. And that also shows me that opposite angles are supplementary because 90 plus 90 is 180. Now I need to find 2 and 4. Well, let's start with 4 because I have the measures of these arcs right here. The measure of angle 4 is going to be 1/2 of the intercepted arc, so 60 plus 80. So it's 1/2. 60 plus 80 is 140. So the measure of angle 4 is going to be half of 140, which is 70. Now angle 2 is opposite it, which means it has to be supplementary to it. So the measure of angle 2 is going to be 180 minus 70, which is 110, because those two together have to add up to 180. Now there are other ways that you can find all of those angles, but that's the quickest and easiest way if you can remember those theorems. Now here's another theorem. We have tangents and intercepted arcs. The measure of an angle formed by a tangent and a chord is still half the intercepted arc. So even though the angle is not inscribed, if we have the tangent and a chord, this is going to be half of the intercepted arc. Okay. So if we look at this example, segment SR, or line SR, is tangent to the circle at Q. If the measure of arc PMQ, that's this one, is 212, what is the measure of angle PQR? So we're looking for this angle here. Well, these two angles together form that line, so that means they have to add up to 180. I know this arc, which means I can find this angle because it's going to be half of it. So if we think of the measure of angle PQS is 1/2 of 212, which makes it 106. And the measure of angle PQR is supplementary to that, so it's 180 minus 106, which leaves me with 74. Okay. Looks kind of complicated to start with, but actually pretty simple once you get going. Now let's look at this problem. If KJ is tangent to circle O, what are the values of X and Y? So KJ is tangent. Well, if I start by looking at Y, I notice that I have an angle here inscribed in a semicircle, which means that's a right angle. I have a triangle. I know that all three angles in a triangle have to add up to 180. So 90 plus 35 plus Y has to be 180. Okay. 125 plus Y equals 180. So if we subtract 125 from each side, we get a value of Y equals 55. So that makes this 55. Now to find X, I know that the measure of angle LJK, all right, that's the angle that I'm looking for, LJK, is going to be 1/2 of the intersected arc, which in this case is arc JL. Okay. Well, if I also look at JL, right, which is this arc, it's intersected as well by this angle. Well, they intersect the same angle, which means that those arcs have to be, or those angles have to be congruent because they intersect the same arc. So X has to be 35, right? I could also look at it and say, well, arc JL, if I go back and I use this idea of 70, and I could work it through that way, but since I noticed that that arc is intersected by this angle as well, they have to be the same. So we get a value of 55 for Y, a value of 35 for X. And that concludes our discussion on inscribed angles today.